A long algebraic equation often looks like a jumble of abstract symbols. It is easy to treat these variables as rules to be memorized rather than coordinates with a specific location in space. We are going to take those complex polynomials and translate them into specific points and curves on a coordinate graph. To do this, you only need 3 physical tools: a sheet of graph paper, a pencil, and a drawing compass. Algebra is the language used to describe geometry. When you organize these numbers correctly, you are extracting the dimensions needed to draw them. Step 1 is looking at this equation. To find the center and radius of the circle described here, we use a reorganization method called completing the square. First, separate the variables. Move the -1 over to the right side of the equal sign, where it becomes a positive 1. Then group the x terms together and the y terms together. For the x group, take the middle number, which is 4. Half of that is 2. Square that 2 to get 4, and add it back into the x group. Do the same for the y group. Half of -2 is -1. Square it to get a positive 1, and add it into the y group. You must keep the equation in balance. Because you added a 4 and a 1 to the left side, you must add a 4 and a 1 to the right side. The right side now totals 6. Finally, condense the groups into their squared forms. The equation is now written as x plus 2 squared plus y minus 1 squared equals 6. This format provides the coordinate instructions we need to begin drawing on the grid. To draw the circle, we first need to identify the exact coordinates for its center. Look at the +2 and -1 inside the parentheses. When plotting the center, you invert these signs. The +2 becomes a -2 on the x-axis, and the -1 becomes a +1 on the y-axis. Your center is at -2, +1. The number on the right side, 6, represents the radius squared. This means the physical distance from the center to the edge of your circle is the square root of 6. Place the point of your compass on the center coordinate, set the width to your radius, and sweep the lead to create the circle. This proves the definition of a circle. It is simply the collection of all points that's set at a constant distance from a fixed center. Next, we will add a straight line to the same graph by determining its slope. Slope is defined as rise over run. It is the vertical change in y divided by the horizontal change in x. We will plot a line that passes through the point 3, 1 with a slope of 2. To use a whole number as a slope, treat it as the fraction 2 over 1. This gives you both your vertical rise and your horizontal run. Start at the point 3, 1. Run horizontally to the right by 1 unit, then rise vertically by 2 units. This marks your second point at 4, 3. Instructional tone. Avoid mixing up the axes. The horizontal move is always the denominator, and the vertical move is the numerator. Use a straight edge to connect these points, extending the line across the paper. Slope defines the relationship between the horizontal and vertical. It tells you exactly how the line will behave as it moves across the grid. Look at your completed graph. By following the algebraic steps, you have turned abstract values into a concrete geometric scene. You have now visualized the 2 main ideas of coordinate geometry: a circle representing constant distance and a line representing a rate of change. These are the fundamental concepts required for calculus. Understanding how to graph constant distances and rates of change allows you to eventually analyze how more complex shapes and curves move and evolve. Visualizing these equations makes the underlying math more intuitive. Every standard equation has a specific physical shape, and once you can graph it, you can see how those variables actually function.